So in our last lecture, we looked at stone, natural occurring material that has to be harvested from the earth, but that has these very good strength characteristics. And in this lecture, we will look at what happens when humans actually make the stone or make the masonry that they're going to use. So switching from harvesting stone to actually making brick, and as we'll see, concrete, often called artificial stone. And to do this, we'll start by looking at the way bricks are made, the material properties that you end up with from them, how you can improve them, and how in particular one building culture, the Roman building culture, really relied on brick for not only its kind of day-to-day building, but also some of its grandest projects. Now, we talked about the fact that Roman builders were very fortunate to have a huge palette of stone materials to work with, both locally and as the empire expanded its reach from Africa. But if you look at the map of the Roman region, you can see that the city is also based in the Tiber River Valley. And river valleys are very good providing clay that can be used to make brick. And in fact, in addition to archaeological evidence for all of the stone quarries around the city, there's good evidence for brick-making facilities where clay was harvested from from either the Tiber or one of its tributaries. And then, as we'll see, the land was used to actually make the bricks. Important to construction, but also it would eventually become a very important political thing as well. It was one of the ways that aristocratic families could actually make money, and so brickwork in major public monuments was both a sort of good thing for the citizens of Rome, but an even better thing for the owners of these massive brickyards. We had looked at the kind of library of stone that Roman builders had and talked about it in terms of its relative strength and workability. So the local travertine, very, very good compressive strength, but very workable. And Roman builders in later years, of course, had access to granite and basalt from both Egypt and the Italian peninsula that was much, much stronger, right up to 3,000 kilograms per centimeter, but very, very hard to work. When we make brick, on the other hand, we end up with a much softer material and a much weaker material, but one that's much easier to shape to the tasks that we want it to achieve. So we'll look at two types of brick, mud brick and fired brick. And as you can see, there's a huge difference in compressive strength. And tensile strength, even at its best, brick has very little reliable tensile strength as well. You can see that both of these materials, though, are relatively workable. It's fairly easy to carve brick once it's out of the yard or out of the kiln. And of course, very easy to shape it because we're actually molding it into the forms that we want. So we'll start with mud brick, the simplest way of making masonry. And here you see techniques that are still used today to make bricks without firing them, just letting them dry in the sun, sometimes called sun-dried brick. Here on the left, you see workers who have gathered clay, probably from a river bottom. They've mixed it with whatever sort of soil they have to make it workable, and you can see that they're incorporating straw, which will give it at least a little bit of tensile strength, just enough to make the bricks hold together. The kind of mud paving is carved up into what will become the sizes of bricks, and then, as you can see, they are simply allowed to dry out in the sun, often for weeks at a time. Vitruvius wouldn't trust any brick, he said, that wasn't sun-dried for less than 2 years, but you get a certain amount of strength well before that. And as you can see, this is a labor-intensive and time-intensive process. And building cultures that use mud brick today tend to be in places where labor is very cheap, materials are very abundant, sun is very reliable. And as you can see, it is not a fast process, but it's one that can produce a relatively large amount of building material relatively cheaply. Mud brick has characteristics that give buildings built with it very, very obvious, distinct sizes and proportions. It, like the material it's made out of, is very subject to deterioration when it hits water. So even though it is sun-dried, the material is not that much more resistant to being washed away or dissolved than the actual clay is. And so when you see mud brick buildings, they are typically clad in often a kind of protective skin of stucco or something else to try to keep as much of the water off as possible. Maybe one of the most intriguing examples of mud brick architecture is the Great Mosque of Djenné in Mali, which was originally built centuries ago. And as you can see, it has this very characteristic, like extremely massive walls, because it takes an awful lot of cross-section to get the structural capacity that's being asked of it, right? It's relatively weak material. Clad in stucco to keep as much of the rain off as possible. And then you can see the logs that are sticking out from the walls, or they're partly to hold the brick together. They're sort of tensile reinforcement, but they are also a kind of permanent scaffolding to allow people to come up and repair the stucco, or, as is often the case, to actually rebuild portions of the wall that have deteriorated from being left out in the rain. This building has a particularly interesting history. The original mosque was the subject of a theological dispute. A local leader decided that it represented a sort of decadence that he and his followers didn't approve of. So he wanted to destroy it, but couldn't be seen to sort of actively demolish a sacred building. So what he did was he ordered the gutters to be blocked up, and the rainwater, instead of cascading off the building, built up on the roof, eventually soaked into the walls and destroyed the building on its own eventually. The mosque was rebuilt at the beginning of the 20th century. It was controversial because the reconstruction was led by French colonialists who included forms and symmetries, as you can see here, that weren't necessarily part of the local tradition. But they relied on local labor and local craftsmen to make the bricks and to actually assemble them into walls, and that is still done today, that there are still craftsmen who work pretty much full-time on maintaining and keeping up the building itself. And so this is another example, as we were looking at the example of the Ise shrine when we were talking about timber, of the kind of shortcomings of the material translating into an important element of the local culture, where the process of rebuilding and maintaining is an important ritual to the surrounding city and the surrounding region. And what we might think of as a weakness in the material structurally is actually a sort of strength socioculturally. Mud brick is not very strong on its own, and so when we see walls built of it, we often see things that we recognize as reinforcement being added into it. So in Egyptian bricklaying, a mud brick building culture, we see mortar being used that is pretty much the same formula as the bricks themselves, so relatively weak, but strengthened, as you can see, with layers of grass that again provide a sort of rudimentary tensile reinforcement that gives the walls just a little bit of bending strength. And here too you can see over on the left that Egyptian brick was always clad with mud plaster or stucco, again reinforced with straw or grass to give it a little bit of robust tensile capacity. Now, if we go kind of up the ladder one level of strength, we find another type of brick that the Romans really perfect in their imperial building culture in particular, and that is kiln-fired brick, where you use the same process to shape the bricks with wet clay, but instead of allowing the clay to dry slowly in the sun, you put it in a kiln that very rapidly, or comparatively rapidly, really burns off all of the water in the clay and gives you that additional strength, roughly twice the strength of mud brick. At its simplest, an open-air kiln simply puts the wet clay in the center of a mound of flammable timber and sticks, the mound is burned and the clay is subject directly to the heat of the fire. The Romans and other brick-making cultures have figured out that if you have what's called a vertical kiln, where you separate the combustion chamber where the fuel is from the firing chamber where the brick goes, you get a slightly more consistent firing of the brick, and you do not get the kind of smoke, discoloration, and things that you would get in an open-air kiln. So we see evidence throughout the Roman world of kilns being used to produce bricks. And the Romans knew that in a firing chamber, the bricks that were closest to the combustion chamber would be stronger, but also harder to work. The bricks that were at the top of the firing chamber would be softer but weaker. And there's evidence that brickmakers marketed basically the different types of bricks according to where they had been in the firing chamber. Kilns are used even today to make bricks. Here we see examples of them throughout history. Medieval brickmaker on the left, you can see pressing clay into a wooden mold, and a kiln in back, clearly fire coming out the top, and it looks like they're putting fuel into the combustion chamber below. More sophisticated conical shapes that really stratify the brick in the firing chamber and give a real much stronger brick in the base of the kiln and a much weaker brick at the top. A spherical kiln in the upper right that produces a more even heating throughout, and kilns today being used in Central Asia to manufacture bricks, very much something you would have seen probably in Roman brickyards as well a couple thousand years ago. Roman brick was standardized. The standard Roman whole brick was about 30 centimeters by 30 centimeters, so a little bit more than a contemporary foot by a contemporary foot. And for most building, it was divided in half, either along its axis to create a rectangular brick that we would recognize today, slightly longer in proportion than the 4-inch by 8-inch brick that we're used to seeing, or it would be divided in half along the diagonal, creating two sort of sandwich shapes. And as we'll see, this had a particular use in a very special type of wall itself. But the Romans also got very good at what today we call terracotta, which involved a lighter clay that could be molded to much tighter dimensions. And terracotta was used not only for flooring tiles and roof tiles, but also for more complicated shapes. As you can see, the kind of thermal, the hollow shapes that were used, as we'll see in hypocausts in Roman baths. This was essentially the ductwork that moved heated air through the fabric of Roman baths. And you can see that's a very difficult shape to mold, but terracotta is light enough that the clay can be wrapped around the mold and fired successfully in a kiln. So a tremendous variation in sizes and shapes, but also a standardization of the typical structural brick that would be used throughout the empire. Now, brick, of course, has to be sort of glued together, and to do that, there are a couple of different types of mortar that the Romans used. The simplest was lime mortar, where they would simply take limestone, crush it, fire it so that it would remove most of the carbon, and then wet it. And when wet, slaked lime begins a chemical reaction. It first creates calcium hydroxide. The calcium in the lime bonds with oxygen in the air. And then over time, long periods of time, it continues to react with the carbon dioxide in the atmosphere. And eventually that calcium hydroxide becomes calcium carbonate, essentially limestone reconstituted. So this is literally artificial stone. Lime mortar, relatively easy to make if you have access to good limestone, but it is non-hydraulic, which means that it needs to be in a perfectly dry condition to actually set. This is problematic, of course, if you're building in a rainy climate. You can protect the wall while the mortar is setting, but it takes a long time to come up to strength, so it's very difficult to build multiple stories with lime mortar. Being in a volcanic region, though, Roman builders also had access to what was called pozzolan, which was a volcanic ash that had a much more complex chemical reaction when it was wet, and could be used even underwater, would set even if it was completely surrounded by water. So Romans used pozzolanic cement to build breakwaters, to build harbors, but it was also used in building construction because it had other advantages. In addition to being able to build in wet conditions, it set much quicker, which allowed for faster multi-story construction, and it came to its ultimate strength much more quickly than lime mortar. Now, mortar is almost invariably weaker than the brick or stone that it's holding together, but as it fails or crushes, those bricks or stones either come to rest on stronger elements within the mortar itself or on each other. And so as the mortar sort of crushes and the wall settles, it finds the kind of most effective load path for each brick within the wall. So while holding it together, it's also allowing the wall to kind of settle itself. Now, Romans used mortar in much greater proportions than we're used to using today. When we look at a Roman brick wall, we see these, what to us feel like very chunky beds of mortar in which the brick is laid. And that sort of makes sense, that mortar was easier to come by in some ways than brick, and much in the same way that we use aggregate in concrete today to sort of take up space, to stretch the expensive cement farther. Roman bricks and walls can be seen almost sort of as a kind of man-made aggregate that's used to extend the reach of the mortar itself. And here you see mortar being used to bond bricks on the bottom and tufa, lightweight pumice-like stone on the top. And again, much thicker beds, almost like a concrete wall with regularly spaced aggregate. A Roman bricklaying job site would look very familiar to bricklayers today. This is a painting in a tomb of someone that we think was a building contractor. And all of the people in the picture, all of the techniques have come down to us and are still used in bricklaying today. So we have the two skilled craftsmen on the top with their trowels putting mortar on top of one layer of brick. We have a hod carrier climbing up the ladder with a tray full of mortar that's going to be used to extend the wall its next level. On the lower right, we have a laborer carrying the bricks themselves, so that the bricklayers will have access to a kind of constant stream of material. And in the lower left, we have someone who's actually mixing the mortar with a giant hoe, so that the mortar will always be fresh, right? It'll always be pliable. And Romans eventually used brick, particularly in the imperial era, for just about every form of construction they had. On the left, these are the ruins of Ostia, the port town outside of Rome. On the left, you see what appear to be commercial structures, warehouses with very large openings at the base. They might have been shop fronts or just storage rooms. The paving, incidentally, is basalt, so you go from very strong, very hard to work material in the paving to this much more easy to work, mass-produced brick in the buildings themselves. And the overview is a shot of what was the residential district of Ostia. And the residences that the Romans built out of brick were maybe could have been some of the most impressive buildings in the cities. Most of them are lost now. But we have evidence in ruins on the upper right, the remains of an insula or apartment block at the foot of the Monumento Vittorio Emanuele, so right in the center of Rome. And you can see that it is very thick, dense brick construction, so we think there must have been additional floors to this, with the rooms almost feeling like they're kind of carved out, probably commercial vendors on the street level, and then residential apartments above. The lower right is a probably fanciful reconstruction of what this must have been like. Vitruvius, in writing about brick, he doesn't cover brick as much as he does stone. Given the time he was writing, as we'll see, that was probably reflective of the times. But he does talk about insulae, and he talks about them as the result of people wanting to live close to the center of the city, and this kind of press for residential space You can't put everyone on the ground floor, he says, so the buildings have to go high, right? You have to start stacking apartments. And he says, in these tall piles reared with piers of stone, walls of burnt brick, so notice not mud brick, but fired brick, and partitions of rubble work, what we would call concrete today. The upper stories can be partitioned off into rooms to very great advantage, right? They can be made into apartments. And Roman people thus easily find excellent places in which to live. He's describing the skyscraper, basically, but doing it in Roman terms. We do not really know how tall these went. We can assume that the 5 or 6 stories was probably a fairly standard height based on the size of the remaining walls and how strong we think they would have been. But there's textual evidence that they may have gone taller. One Roman poet in particular, Martial, who writes about climbing the 200 steps to an apartment, which if you do the math suggests maybe 7 or 8 floors instead of 5 or 6. We don't know, of course, but we think that the apartment blocks probably would have been limited in height more by the number of stairs people could climb, more than the structural capacity of the brick itself.